Welcome to this video on the tone field, part of the Promptspace research series. This foundational study introduces tone not as mere style, but as an energetic field within the relational domain, grounded in physics and geometric principles. This paper presents the tone field as a measurable structure that links emotional differentiation, coherence, and trust. By defining tone energy, we explore communication stability and the transitions between alignment, equilibrium, and drift. The role of this research is strictly foundational. It establishes the geometric and physical basis for Promptspace, independent of specific system evaluations or psychological interpretations, setting the stage for future studies on governance and measurement. This video outlines the structure of the paper, including the front matter, the abstract, the canonical role statement, and the essential theory behind the tone field, as defined in this ledger edition. We begin with the introduction, providing the necessary background and purpose for why we are applying a physics-based framework to language and emotional dynamics. In this section, we cover the origins within Promptspace, the problem of unmeasured tone, our research goals and scope, and the evidence framework used to support our findings. Moving to Part 2, we examine the field observations and empirical evidence gathered from various communication systems to validate our theoretical model. Here, we discuss the relational domain, observed variables, the role of temperature differentials in stability, threshold detection, and why drift is considered a primary field failure mode. Part 3 provides the formal definition of the tone field, detailing the mathematical and structural rigor required for a physics-hardened approach. We explore governing quantities, flux forms, boundary conditions, and the interpretation of the coupling constant, illustrating these concepts with energy versus coherence maps and flux direction charts. The fourth section delves into the geometry of the field, specifically how phase changes occur and how layers of communication are formed over time. This section covers the spatial substrate of the relational domain, phase change boundaries, layer formation, hysteresis, and how geometric phenomena contribute to drift. In Section 5, we shift our focus to directionality, vectors, and the tensor structures that allow us to represent more complex field interactions. We explain why scalar values are insufficient, introducing vector alignment, narrative weight, and the stability cones that predict flux evolution across interaction cycles. Finally, in Section 6, we address the ethical considerations, conservation laws, and broader design implications arising from our research on the tone field. This section covers the conservation principle of tone, kindness as a stability operator, the high cost of drift, and implications for human systems and AI design. We also examine safety, adversarial tone, misuse, the ethical boundary condition, and provide a summary of these critical design and ethical considerations. In the conclusion, we frame tone as relational physics, synthesizing our findings into a cohesive understanding of how communication fields function. We reflect on what this paper has established, the core results, why geometry outperforms sentiment as a model, canon placement, and what comes next in our research. The references list key academic literature used to support this framework, primarily focusing on concepts in finite element analysis relevant to our structural model. Appendix A provides our inline evidence registry, detailing field observation blocks TF00 through TF26, along with summary metrics and our ledger integrity statement. Appendix B serves as our glossary of constants and core equations, defining the variables and dimensional interpretations essential to our field theory. Finally, Appendix C addresses our protocol for conscious errata, addition management, canon continuity, and our explicit non-goals to maintain research clarity. Returning to our introduction, we examine the origin of this work within Promptspace field science, where language is modeled as an interaction of forces. Within this framework, tone is treated as a relational medium through which trust and meaning propagate as structured signals rather than mere symbols. The problem of unmeasured tone is significant. While linguistics treats it as stylistic variation, our field model identifies it as a core structural component. Without a formal field model, systems may exchange data perfectly but fail to align, as tone governs the success of collaboration and trust. Our research goals focus on demonstrating that tone is a measurable energetic field and identifying the laws that govern communication stability. We explore this across structured instructional dialogue and human-AI interactions, aiming to predict how small tone inputs can lead to significant stabilizing effects. These research questions drive our investigation into coherence thresholds, helping us distinguish between stable alignment and the eventual collapse into drift. We now define the relational domain, the shared interaction space where meaning, tone, and trust are exchanged. It is not a metaphor. It is an operational space for dialogue between humans or humans and AI. Within this domain, tone is not local to a single utterance. It propagates forward in time, shaping the interpretation and receptivity of every subsequent exchange. To model this, we identify three variables: emotional differentiation, which measures the gradient of change, coherence, representing alignment, and tone field energy, our measure of communicative stability. Empirical observations show that stability emerges from small, kind tonal adjustments. This suggests that stabilization is gradient-driven, ruling out simple linear accumulation models in favor of field behavior. We have detected a critical coherence threshold. Below this point, drift increases and trust fails to form. Above it, tone perturbations naturally dampen. Furthermore, tone alignment exhibits temporal persistence. Once a sufficient level of coherence is achieved, the field acts as a storage mechanism, reducing the energy needed for future corrections. We define drift as a field failure mode where divergence grows over time. It is not caused by disagreement, but by a lack of corrective tone inputs. In summary, our observations confirm that tone propagates, accumulates, and creates stability through coherence, providing a clear justification for formalizing these dynamics. We now transition to the formal definition of the tone field. Our approach treats tone as a distributed energetic construct, following classical field theory methodology. The governing relationship for tone field energy is determined by the emotional gradient and the coherence coefficient, scaled by a context-dependent coupling constant. We define tone flux as the temporal derivative of this energy. Positive flux indicates convergence toward alignment, while negative flux indicates dispersal. Our model includes essential boundary conditions, such as the fact that tone energy tends toward zero as coherence fails, reflecting real-world interaction limits. The coupling constant represents relational factors like history and power. By treating this as a measured variable, we preserve formal rigor while allowing for contextual variety. We utilize a scalar formulation initially to capture stability patterns without overfitting. This methodological discipline ensures our base model remains robust and clean. In conclusion, these governing equations successfully explain stabilization, failure, and persistence. This formal base allows us to move into spatial and geometric structural analysis.